Hello, welcome to Cephalocon. My name is Theofilos Mouratidis. I'm a cloud engineer at Switch. And here I'm going to present you what we do at Switch with Ceph. So, who is Switch? We're basically the Swiss NREN. This stands for the National Research and Education Network. It's basically a non-profit organization, and it's a foundation with the goal to provide IT services to schools and universities of Switzerland. So some of the services that we provide are cloud, network, security, but also legal in the IT context. We are also the registry for the .ch and .li country code top-level domains by Ofcom, and we do it on behalf of the Swiss Confederation. So who are we? We are Cure. We are the Cure Circle of Switch's cloud team. This stands for the Cloud and Other Cloud Reliability Engineering. We are divided into compute, network, and storage, so we work with Kubernetes, OpenStack, and Ceph. 4 of us are here. At Cephalocon, we are focused on storage, and we do Ceph and a few other solutions. Our main use case for Ceph is S3 and then RBD. So here are our storage solutions, the total ones that we have. The 2 that you see on the left are our legacy systems, and the 2 on the right are the new ones. So the first one is the Object Store version 1, which is based on Ceph. This is basically for our product called Switch Engines. And this one is basically like a skin of OpenStack Horizon. So we have like OpenStack that integrates with Ceph, and then we basically provide an OpenStack service to our clients. The second one is our Object Store version 2. This is based on Cloudian Hyperstore. And this is to provide an S3 service for engines. So we add this component to the current Switch Engines product that we have. And this is mostly used for Vim backups. So for example, we have like a lot of universities, and they really want to do the backups with Vim, and we use this product. Now, for our next iteration, we have like the Switch Cloud portal, which is basically a service broker that gives different types of services, such as like compute, S3, and Kubernetes as a service, using like Kubermatic, for example. And we use like 2 of those, which is like the Switch Cloud Compute. So this is based on IBM Flash Storage. And this is to integrate with the OpenStack to be able to provide like volumes, images, multi-attach volumes, etc. And then this is the main point of the presentation, which will be the Object Store version 3 that we have developed, which is basically to provide the S3 service for the Switch Cloud platform. So those are like our production clusters, so you can see a little bit our scale. We'll have the first 2 clusters that are basically for the OpenStack. We'll have like the OpenStack in 2 regions. One is in Zurich, the other one is like in Lausanne. They are around like 20 petabytes of raw capacity. Recently, we updated from Octopus to version 17. Then we'll have the 2 OSv3 clusters, so the new ones, which are called Albinia and Bien. We named them from like Swiss lakes. We are using the latest, let's say, Ceph versions, but we also create our own images. So for example, our new clusters, they have like full IPv6 support. So we have done a lot of like a pull request to the main repository to be able to support like full IPv6 support for Ceph itself and Ceph ADM. Bien, we just deployed it like last week. We're now experimenting a little bit with the new version, trying to see like what works, what doesn't, how we can improve on that. And then we have the other 2 Cloudian clusters. I'm not going to talk too much to them about that. We're trying to phase them out. So OSv1 and OSv2, they are basically Ceph and Cloudian on life support. They are just like, we just maintain them. So for example, if something bad happens, we don't replace OSDs, we don't do anything, we just like try to keep them alive. The only way that we want to like keep them alive, for example, for OSv1 that is based on Ceph, is to be able to get like new hosts. And then you get this this thing called like the ship of Theseus, where something gets something gets like broken, and then you replace it, and then after you have broken everything and you have replaced everything, you come with like a brand new cluster in the end. Ceph is like quite sophisticated compared to Cloudian, so you are able to do something like that, but Cloudian is not. We had like lots of issues because, for example, apart from just upgrading from like one version to another, you also have to upgrade the OS as well. And then we had like tons of like painful problems, and then the upgrade took like a long of time. And then in the end, like the moral of the story is like try to keep your hosts up to date. Like if you have your hosts up to date, then you don't have to deal with all those problems just like bunched up in a small time frame. Then we have Cloudian. The problem with Cloudian is that the capacity is getting full. The issue with the system is that it's not that elastic compared to Ceph. So it's like very hard to be able to do like replacements and expansion. So what we have done instead is that we try to expand our previous system, which is like Ceph, and then expand this one, and then move data from Cloudian back to Ceph. So OSv3 is basically trying to learn from the past and try to improve the future. So OSv1 and OSv2 use the classic DevOps model. So basically you have a bunch of Ansible scripts, and then to be able to configure the services, and then you basically push the configuration changes to the host. So this, at some point, can create some problems. So for example, some of them could be the inconsistent configuration. Let's say with Ansible, you say, OK, I'm configuring my Ceph cluster in this way. But then you go into the server, you SSH into it, and then you change the configuration. Ansible doesn't know that. And for example, let's say you have left the OSD pull delete flag to true, and then that would be, for example, detrimental. So you will need a system that actually, a way to be able to say that the code that I have that deploys is actually what's happening in my hosts. And then there comes basically the GitOps. GitOps is like an improvement on DevOps. So basically you have like a source of truth, which is a repo, and that defines how it's your like infrastructure and code, like how everything is configured. So for example, you have the actual state and then the desired state. So, and you go back and forth. For example, let's say you add a few commits that you want to do a few changes. So then you have a desired state, and then you need to create the tooling that is able to get you from the actual state to the desired state. This is basically what I have talked a little bit before. So to be able to have like the single source of truth, you need to have stateful configuration and continuous delivery. The tools that we use, it's basically Ansible. Of course, it's not the first thing that comes into mind when we're talking about GitOps. It would have been like Flux or Argos, etc. But what we're trying to do is that since we have already knowledge of Ansible, it's really easy for us to be able to create it in such a way and add like tooling on top in order to be able to deploy configuration in a GitOps way. Then we also use Terraform. This is basically to provision our staging and testing clusters. They are based on the OpenStack VMs. Basically, we use the Switch Cloud Compute service for that. And with this Terraform, in the end, once it provisions everything, the network, etc., it provides Ansible with like user information like inventory, IPs, vars, files, templates, you name it. And then we have GNU Make. Basically, this is like to make the DevOps life easier, to be able to like to create targets, and then with this, we can do changes ourselves or through a pipeline, depending. This is the first repo. This is the OSv3 Ansible collection. We are heavily, as you figured out, we are heavily focused into Ceph ADM. This collection at the start was based on the upstream collection from Guillaume Arbiou from Red Hat. But then we added lots of stuff, and then at the end, it became its own thing. So we just like created our own thing, and then we use this, the upstream Ceph ADM collection as a dependency. So what I'm trying to say here is that the roles and modules like have distinct tasks that are related to hosts. So for example, a role will have something to do with like hardware or network or prerequisites. So for example, our roles, we have made them in such a way that they don't actually do many things, and they just do like one thing, and then basically with that you create like a modular code that is like easily expandable, easily debuggable. And it's like quite easy to understand even if you see the code after like 12 months, etc. So for example, if you want to update the firewall rules for OSDs, you just run the firewall role. So every role just does like a simple thing, and that's, let's say, our philosophy on how we create that collection. Then we have another repo This is the configuration management repo. This is basically the repo that glues like everything together to be able to provide the S3 service. So this is the main repo for the CI/CD. And this contains the cluster-specific information. So for example, you have the inventories, dynamic inventories, variables, dynamic variables. We have like scripts that like do a lot of stuff, and we have like lots of playbooks. And then the playbooks basically they are focused on the action that the dev person would do. So you would have something called like update firewall rules YAML, drain and node YAML, move a daemon YAML, update spec YAML, add a node YAML, just do things like that. And then inside that, there will be a series of roles that run and do the task that you would want to do. And this basically requires the OSv3, Ceph ADM collections, Ansible POSIX, and community general. And all of our roles have, for example, default variables. So basically, you can just have like an inventory in a file, run make bootstrap, and then you have already like a Ceph S3 cluster that you can use a few minutes later. As you can see here, our inventory, we have, for example, FQDNs for our host names, and then we use the labels. The labels have like two uses. One of them is to be able to integrate with Ceph ADM, and the other one is to be able to understand what type of configuration you would do. So for example, let's say I want to run the firewall role, and in this one we have different sections based on the labels. So the labels are the ones that place the containers, so then the labels define what type of, for example, firewall rules, etc. you want to have. So let's say we have like the second host that has like the mon, mgr, and OSD role. Basically, it will basically get like those daemons, and then everything will be configured based on the labels that it has, and then Ansible like reads those like labels and then acts upon that. Now we're gonna like show a little bit some of the roles that we have. We have like a lot of roles. One of them, for example, is the Ceph config role. So with this, you see like one input variable that here we state, for example, how our configuration would be. As you can see here, we have like bind IPv6 true and bind IPv4 false. All of our classes are like fully IPv6, as I said before. And then this basically sets the config values, and everything that is not here, it's getting deleted. So for example, if you have something that you have forgotten, and then the next time that this runs, basically it cleans up the configuration, and then you have exactly what you have defined in your code to be able to have the guarantee of the source of truth for your repo. This is like a double-edged sword because, for example, we have Ceph ADM and then Ceph ADM Bootstrap, and when you deploy other configurations, deploy other containers, Ceph ADM itself would generate a few config entries. So we added like a variable, another one we don't show here. Basically, that just whitelists those entries, and then you don't accidentally delete them and then have issues with your cluster. Here is, for example, like the crash role. Here you can see a few variables. For example, you are able to set the EC profiles. You are able to set like the crash tree. As you see, we don't have the OSDs there because mainly we care about the failure domains. So you can define everything there, and then Ansible will have like will create the appropriate pools, etc. Everything is stateful. That means that whatever changes you do, the modules that we have created will figure out what types of changes need to be done in order to get to those like defined variables. The only thing that we don't have right now is basically, for example, if we remove one pool entry, it won't actually delete the pool because that would be detrimental. So we are trying to find, let's say, a safe way to still be stateful and safe at the same time. All of our roles, they support diff output. So for example, you can run Ansible's blah, 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 something cd, and then it will tell you exactly what it's going to do, and then you know what will be the expected output of the Ansible deployment. And here we have, for example, the multisite role. this variable name has changed, but in the end, like this is like how we do automatic deployment for multi-site clusters. So basically, you have a variable that is being read by different inventories, and then here you have like a unified schema for all your inventories that says like how are the realms, the zone groups, and the zones. So as you can see here, we have OSv3 as a realm, ZG as a zone group, and then we'll have like two zones that will be able to replicate themselves. As you see under the zones, we'll have the cluster name, basically the cluster name and the inventory name match. So when we deploy with like GitLab, we know to which inventory to point to. So when an inventory runs this role, basically it will go through that tree, find out which zones it belongs to, and then it will actually deploy those specs and set up all the multi-site metadata. I have something here called ensure variance is consistent, but that's only if all your variables are inside inventories, then you just want to know that this is like copied, etc. This is not stateful yet because like it's the latest thing that we have done, and then we want to add a lot more things. So for example, how are you doing replication from which bucket like to which bucket, or from which zone to which zone, etc. And here is like a bit of the diagram for like how we do deployments. We have like different diagrams from like different types of like changes. So with GitLab, we have MR triggered pipelines and periodic pipelines to be able to ensure this the single source of truth. So one of the steps that happens in like our pipeline, basically we do like a git diff, and then we figure out which inventories have changed, and then based on that we deploy to the appropriate clusters. This currently runs like all plays, so all the playbooks. This is a bit slow, but next time we'll figure out like let's say to be able to figure out which playbooks exactly to trigger based on which variables have changed between a feature branch and a main branch. This is all done basically for the Switch Cloud portal. The Switch Cloud portal, as I said before, is like a service broker, and OSv3 basically aims to provide S3 as a service. So you can have organizations, you can have projects, you can have like members, member management, etc. Our portal team has created like a front end for it. We tried to use Ceph dashboard, but we had the issue that there is like no multi-tenancy, and the way that it's designed is basically the users are like admins. So if you are like service provider, the user and client is like a different entity. This is like a preview. I will actually like show it live how it works. So for example, here you can see that like this is my project. I have compute, an S3 instance there, and like members. There's also cache, but they don't have like the feature flag to be able to use Kubernetes as a service. And here you can see like the S3, how it looks. So for example, you know like at which endpoint you use, like what are your access keys, and then you can create like buckets, etc. We will be adding a lot more. Right now we will be adding like multi-site. We will also be adding S3 browser, also to be able to create bucket policies, lifecycle policies, etc. through a UI. This is done by the portal team, and this integrates with Ceph via the Rados Gateway admin HTTP API. So OSv3 CM in a nutshell is basically like a GitOps style automation for Ceph ADM. It makes deploying clusters like quite trivial. So for example, we get like let's say lots of hardware, and then the only thing we need to do is basically to just create the inventory. We already have like an inventory template that we copy, we change a few variables, and then we push a button, and then we immediately have a cluster out of it. It has like an initial learning curve because the way that we do Ansible is like a little bit different to adopt the GitOps style deployment. It can be like either simple or complex, as we have like seen in the slides before. You can either have like an inventory in it, but if you want to have like more control, you can like do a lot of changes or change a lot of like variables, like change knobs, etc. With for example, what we provide to be able to create what you want out of it. So the OSv3 collection, basically, we are planning to open source it for other people to be able to use it. It's going to take some time. We are already in like a very good spot. And yeah, it will be helpful. Probably we will like write in the Ceph mailing list in like a year or so, and then we would like request feedback for people to test it, because currently there is no like some way to use Ceph ADM with Ansible, just like a few scripts here and there. The next slide is basically questions, but before we do that, I'd like to show you a few things. So for example, here you can see the pipeline that we have. We have our own GitLab runners. All of them, they use like IPv6. Here, basically, this is the step to configure the images. So we have an image for the CI that runs the Ansible, etc. We have another step that basically either sets or builds. What? Oh, it doesn't show. Sorry. Probably I need to stop the show, and now now it's there. So here is the pipeline that you can see. So for example, here the first step is to configure the images. So for example, we have a directory called Docker images, and if there is a change like the Docker file or something like that, an image is like built out of that. Then we use like Ansible lint. Then we have this step that I showed before that tries to figure out to which clusters to push. And then we have dynamic downstream pipelines that are deploying to the cluster. So for example, for my configuration that I did, I basically deployed the dev Timo and the dev Timo mult cluster. So there is basically nothing there. When those things run, we basically like create the VMs, set up the network. I'll show you later also the network that we use, etc. We provision already HTTP certificates with Certbot. We have like our own secure name server, and then we are able to add like records, etc. So we are able to do like the multisite testing, because it requires like a HTTPS support. Otherwise, you would have to use HTTP, but we don't want that. And in the end, you get like a cluster, and then you can use multisite with. I'll show you a bit later. So here, for example, is also the Switch Cloud portal, as you can see here. We have like I need to log in. Again, this is like S3. So for example, let's say you want to add a key. Right now, we currently like have like one endpoint, but we will add like many clusters later, and then you can like manage everything, etc. I'll ask the portal team if they are able to provide like open source code, so for other people can use and adapt it to their own needs. So they are able to provide, for example, S3 as a service. And then we have, let's say here, you can see we provide already for our customers support, so they can immediately use their access key and the endpoint with like different types of tools. And also here, if you want, like you can create buckets. You can, for example, enable object locking if you want to put them in some other endpoint, etc. So I can add like a bucket 2 to this endpoint with like this. Yeah, and then you get it, and then at some point when you use like your credentials, like you can like see it later. And here I think I have my clusters. So what I have done is that I have like two profiles called like C1 and C2. Is this? No, it's like quite small. C1 and C2. This is basically the two clusters that I have deployed with multisite. The good thing is that this happens in one go. You don't need to do like to deploy like 2 times to be able to get the replication, because right now there is, for example, in the MGR the Ratos gateway module, but for this one basically you need to first deploy into your like master zone, etc. Then you get a token, And then you have to use that token to be able to add other additional, let's say, zones. But the way that we do it, we just do it like customly, and then in one go you have already like a multi-site setup. So for example, we'll like have nothing here. If I do a sample, do I have this? Yeah, it exists. So I will just copy it. Yeah, it's a bit slow. So we have added our object, and then I'm going to the second cluster, and I was going to do ls, and see we have nothing there, and just wait a little bit, and probably at some point we'll have the object. Yeah, we have it. So yeah, that's it basically. Questions? If you could speak loudly, because
yeah, sure. So in the Ansible inventory file, you have labels, but why didn't you use the groups? So host groups.
This one is because, for example, you can have like the same name in like different groups, and sometimes you would like remove it from somewhere, add it from somewhere. But having the labels, you already have everything that you want. So basically, I mean, I can show. Like in an inventory, basically this thing will be this will be equivalent to like three lines in the Ansible. But right now you have everything in just one, and then you can easily add labels and remove them without having to go up and down to the code to figure out where is your group, where do you want to add it, etc. It's like a little bit of a different approach, basically. So I guess that's it.